Thank you for joining me for this BimlFlex webinar. And what we're going to talk today about is Azure Data Warehouse Automation. Although BimlFlex, we support on-premises data warehouse automation, I'm going to be focusing today more on Azure Data Warehouse and Cloud Data Mart. There was a previous webinar where I touched on a lot of the stuff very briefly. What I'll be doing now is going into some of the stuff a little bit more in detail and showing you the parallelism and how we actually went about building a cloud solution using Polybase. So the first thing we're going to do is we're going to talk about incorporating data. Most of our customers spend most of their time actually in getting data out of the source system, connecting to the source system, configuring CDC, configuring the parameters to extract the data. We see a lot of time spent there. Once the data is out of that source system and in the data warehouse space, whether that's in Azure Blob Storage or even in a persistent staging database, the project seems to speed up quite a lot more because it's just putting business logic on top of the data extracts. I'll talk a little bit about a case study. We're actually in the middle of doing two proof of concepts with two different customers in Azure SQL Data Warehouse, specifically focusing on data marts. They have two different approaches to it, and just talk about that a little bit. And then more importantly, heading to the BimlFlex demo, I think that's probably the most interesting bit of the day. Before I start, I just want to briefly touch on the different Verigen solution options we have. We're going to be focusing on BimlFlex, which is a data warehouse automation framework and full solution built by Verigens using Biml Studio and Biml and all of the most advanced features of the Biml suite. What I'm going to show you today is you can absolutely achieve the result using Biml Express, which is our free tool. You're going to just have to write all that code, figure out how it works. You know, we've spent months and years building BimlFlex, but you can totally do it using Biml Express if you're up for the challenge. You can do it also in Biml Studio, which is what we've used to develop BimlFlex. Again, the tooling is more advanced than the Biml Express version, but you can totally build everything we've built today. I'm going to talk about the BimlFlex workflow here. The first thing we do is we are using an Excel add-in at the moment. There is a modern UI in the pipeline. What we do is similar to Master Data Services, we have an Excel add-in that we actually point. You can use our metadata import wizard that you can import your metadata from your data sources. Once you have your metadata inside of Excel, that metadata is then persisted and kept in a metadata repository or meta vault. That meta vault is audited, so it tracks history, it tracks changes. Every single metadata change that you make will be tracked against who did it and when it was done. So you can roll back your metadata at any point. You can version your metadata. So it's a full versioning system there. That metadata then is going into Biml Studio. So I'll be shifting between the Excel add-in and Biml Studio. What you can think about this is that your analysts, your data models, your data architects will predominantly be using your Excel add-in. And most of our customers spend probably about 80% of their time working with the metadata, and only about 20%, even sometimes less of their time working in Biml Studio, because you only really use Biml Studio to build out your results and to add extension points. So BimlFlex is built on the concept that you can extend it out at any given point. So we have a whole number of extension points that allows you to build out custom code if you want to, if there's something bespoke to your solution that you need to embed into the project. What we're doing is BimlFlex support all of these different layers and all of these different paths to a end solution, with the goal in mind, obviously getting into a dimensional data warehouse or data mart, and then taking that into analytics. What we're going to be focusing on today is basically going to do 1, 2, and then we're going to do 6. We're going to go from source to staging, but actually the staging layer is going to be Azure Blob Storage. So we're going to extract from source into flat files that have been, I suppose, optimized for Polybase ingestion, and then from there we're going to go straight to dimensional data warehouse. I'm also going to show you how you can go from, I suppose, Azure Blob Storage back into a persistent staging database in Azure SQL Data Warehouse. So you can go from 2 back into 2, if that's what you want to do, as many times as you want. We're not going to be talking about Data Vault today. I think what you'll see is whether you go to Data Vault or not, the same principles will apply. I'm going to go through this slide very briefly. I spoke about this in the previous webinar. But what we're going to do in today is we're going to look at the modern data warehouse, so cloud relational data warehousing. We're not going to be looking at big data. What we do is we'll extract our data, we'll put it into blob storage. And once it's in a blob storage, you can use it for machine learning, because the data is prepared in such a way that you can actually go and use it for machine learning, or you can actually use it for Polybase to run into either a SQL Server 2016 virtual machine or into Azure SQL Data Warehouse. And which version or which flavor of those you pick will depend on how much data you want, how much parallelism you want, and ultimately how much money you have. So there's two options of taking data from a source system and putting it into Azure SQL Data Warehouse. You can either go and connect using probably something similar to Azure Data Factory, where you point it at a source table or a source system, and you say, take the data from there and bring it into either blob storage or bring it into into my database. Now, Azure SQL Data Warehouse is not good at merging data. It wants inserts and deletes and updates and that kind of stuff. So going from connecting to a source database and a target database together is not the most optimal way. And what you will do is you will look at a lot of solutions out on the web talking about data migration. It's always about getting the data out into a flat file and copying that flat file across. So we're actually going to be looking at option 2, and that's or source to file, and that's what we've implemented in from Verigen's point of view. We ran some tests, and the option 1, source to staging and source to file, is close on a 10x and above difference in speed of getting your data into the cloud using those different options there. The Azure case study, so working with, I'll talk about one of our customers. It's the same thing here. The first thing you need to do when you're actually looking at your Azure SQL Data Warehouse solution, and some of the stuff is, you may not know this up front, but you may want to design some of this stuff up front. So the first thing you need to know is you'll have a gut feel of what your target or your end state is going to be, whether you're going to run a very small data warehouse or you're going to run a large one. The reason I have this slide up here is, what you'll see is, let's just look at the data warehouse unit 100 here. What that means is that the 08 in the middle there means that Polybase will have, if you've configured the data warehouse unit 100, Polybase will then have 8 readers. In other words, it can read 8 files in parallel. And that's important to know, because as you are building your process to actually export the files, you want to know how big you're going to go to, because you want to make sure that you can get maximum parallelism at your end state there. So just bear that in mind, that we can have different levels or layers of readers, the amount of parallel files that Polybase can read. So let's look at that now. So the first thing we're going to do is we want to go and extract our data from source. Now, we want to be able to extract from multiple sources. Potentially, you may not even want to do any source installation. And what I mean by that is we also have a pattern, although it's a very limited extract pattern, that uses SSIS Express to get the data out. So let's just say you have a customer that are running MySQL, and they want to go to Azure SQL Data Warehouse, and they have no SQL Server on-premise solution. We can actually install SSIS Express on that customer and get that data out. It's a little bit more tricky, but there is a way to do that. The next thing you want to do is, as you're extracting the data, remember those Polybase readers, you want to make that as parallel as possible, or as parallel as you want to make it. The next thing you want to do is you want to prepare your data that you are extracting to make the data ready for Polybase. And I'll show you in a demo what I mean by that. So you want to prepare your data so that it's correct for ingress in Polybase. It has to be converted to UTF-8 or UTF-16. We've picked UTF-8. And then we're going to compress the data at source. Some customers, and that is optional, so you have a flag that you say, well, I want to compress my data or not. We recommend compressing the data because, again, the transfer, where the biggest bottleneck in this project is normally how fast can I get my data into blob storage, and from there it's obviously all in the cloud. Next we're going to go down the path. We're then going to go and use Polybase to load the data either into persistent staging or into a persistent table, or into Data Mart, or a combination of those, as many iterations of those that you want, ending up with a Data Mart that is then ready for analytics, whether you put SSIS, cloud or on-premise, or Power BI over the top of it. You then have your Azure SQL Data Warehouse ready to be used for analytics, which is ultimately the goal of any data warehouse project, is to get the data into your customers' hands as quickly as we can. And without further ado, I'm going to head into a BimlFlex demo and just show you guys how we go ahead and configure this. So what I have in front of me here is metadata that I've already imported. So I've already prepared this metadata and I've already built this out. So I will start making changes and I'll show you the most important things here. This is not about how do you model in BimlFlex. This is going to show you a lot of things. So the first thing we've done here is we actually have a couple of connections set up here. I've set up a connection for persistent staging, Data Mart. They are pointing to Azure SQL Data Warehouse, and I'm using OLADB SQL based. I can actually change this to use straight OLADB instead of ELT. And we've run some tests with this customer that we're doing a proof of concept with at the moment, where we were loading data into Azure Blob Storage and then using SSIS to load the data from a blob storage into the Data Mart, into Azure SQL Data Warehouse. And that took, on about a 2.5 million row table, that took about 15 minutes, which depending on where you work, that may not be that long, but 15 minutes in Azure SQL Data Warehouse space is quite a lot. We then changed this to use our ELT, or stored procedure driven Data Mart loads. And that same process came down to about 1.5 minutes. So there's a massive difference with how you actually load data into Azure SQL Data Warehouse. Then over and above that, what we wanted to do was do a couple of different things. So we then took that same process, and what we did is we said, well, what happens if I actually create multiple files? So I'm going to put just I'll put a 2 in here. Okay, so now what I'm saying is that for this, actually, I need to put a 2 in there because this is source based, not target based. So what I'm doing here is I'm going to say, for this source, when I extract it, I want to create 2 files for every source table. So instead of going into 1 file, I want to go into 2 files. Now, obviously, for this customer, we split it across, I think, 16 files. But again, you split it across as many files as you want. The next thing we did is we said, well, we also want the ability to, so this will be for that package, and I'll show you guys this in a second. The next thing we want to do is we want to have the ability to actually execute multiple extracts of different tables at the same time. So again, we can go at a batch level and say, I want to execute 2 packages in parallel. Instead of having everything in serial, I want to execute 2 packages in parallel. Then the last thing I want to do here, actually I'll just go and set these changes up so they go into the database, and I'll set that up there. The last thing I want to do is we want to have the ability to customize and optimize things a little bit. So I've simulated from AdventureWorks here. I've simulated one of the scenarios we had with our with this customer who was running Oracle, and Oracle, being Oracle, does something interesting. So Oracle has this concept of if it has a subtable, it creates this sort of hash in the middle there. So it puts a hash in there. Now, although you can load that into SQL Server, Polybase does not like that. So what you have the ability is to go and create what we call a model override name, which says that this is my source table, but I want to load it into a table and I want to rename the table. So you can also use this to do naming patterns. So with our import wizard, we can say that we want to have all of our tables needs to be uppercase or lowercase with underscores, or Pascal case. So when we import, we have, I'll just show you here real quick. With our import wizard, we have these table names and columns that you can go and say, you know what, I want to standardize all my names to either Pascal case, camel case, proper case, uppercase, lowercase. So we give you all of these wizards, and then that will put in the model override names for you. It is also good if you have a source system that has very, I suppose, cryptic names in the object, but you do your analysis and you give it proper business meaning names. And those names will then be taken from your source system and be converted into your staging layer. And you can choose whether you apply it in your staging layer or whether you just apply it in your data mart layer. Well, anyway, what I've done here is I've been able to overwrite my name of my target object. And then lastly, what I'm going to do here is I'm actually going to go on this object here called addresses, and I'm going to say that's a fact table, and it's a very large table. So instead of running to 2 files, I'm going to run that to 8 files. So you have this sort of sliding scale of logic here that you can apply, and I'll set current sheet there. Now there's a lot more things that you can do at this stage here, but I'll get back to that in a second when I get into the data mart and the persistent staging layer. But let's just say that's good enough for my sources staging layers. I'll head back into Biml Studio, which, as I said, this is your development environment. The one is your modeling environment or your metadata environment. Once I'm in Biml Studio, I'll just head back here and hit refresh metadata. Before I hit refresh metadata, keep an eye on these polybase tables here, these files here. So if I hit refresh metadata, you will see here that they will all become 2 files now, because I'm going to be exporting my source data into 2 files, and the address one here will become 8 files. While that's, as you can see there, so now I have 2 files coming here, and I have 8 files there. So you can see with just a couple of settings and tweaks, you can decide the level of parallelism that you want in your packages. So it's really nifty, and it makes a massive difference to the performance that you get in actually extracting the data and loading your data. And there's the packages. So I'm just going to go ahead and build this out. And while this is building, I'll just head over here and just show you. This is the one that I built from the metadata before I started changing the threads. As you can see here, I've just opened up the batch here. As you can see here at the batch level, all of these packages are executed in a single thread or in line. And also what you'll see here is that they are in these sort of sequence containers called table pass 1, 2, and 3. What that means is that based on the relationships between the metadata or the tables, if table A relates to table B, it will work out in what order does it need to extract them. So you don't extract all of the tables randomly, you actually extract them based on dependencies. And you can go and override those dependencies with dependent objects. So it looks like the build is finished. So I'll go no all, and I'll reload all here. So the first thing we're going to do is we're going to reload this batch. I set the wrong batch. I'll do this a little bit later on. So sorry, I set that batch and not this one. That's why that's not loaded. So much for showing you guys that. I'll build it in a little bit later on. I'll come back to that and show you guys that. But what I do over here is at the project level, I'll take you through the package that is being created now. So the first thing we're going to do is we're going to extract the files. And as you can see here, this is the one that I set to extract into 8 files. And as you can see here, I have a S-size package that comes in and it's split it across 8 files. And the other guys here, I'll just randomly open one of them. They will be 2 files. So it'll come out and spit out 2 files here. The next step in the package process is actually a script task here. And I'm not going to open up the script task, but one of the benefits of actually using BimlFlex or any Biml product is that all of the code that we generate is 100% standard Microsoft SQL Server code, right? So it's either standard SIS or it's standard TSQL, or if you're using Oracle, it'll be standard Oracle code. But in this case here, so you can go and open these tasks and have a look at what they do. But effectively what this task does here, it does a couple of different things. The first thing it does is it checks if the file is empty or not. Polybase, if you load an empty file up into Polybase, Polybase goes into this sort of infinite loop. You'd think that it would be able to recognize that the file is empty, but actually if you load up an empty file into Polybase and you run a query that says select star from that Polybase table, it actually just goes into an infinite loop and never finishes. So this script task here is quite important. It looks if the file is empty or not. If the file is not empty, it will then convert that file to UTF-8, and it will then compress that file into a gzip file. The next thing we do is we can run azcopy, which will actually load up all of the files. So if there's multiple files, it'll load it up in a parallel stream. And then conditionally, depending on configurations, you can go and archive the files off. But because you've already loaded the file up into blob storage now, you do want to go and archive the files off. So I'm going to go ahead and just execute this, and while this is executing, I'll show you, I will move on to a couple of different things. So the first thing I want to show you, where is it? Here. So this is my Azure Blob storage here, and as you can see, this is empty. So what will happen is in the background, it'll start extracting files, and it'll pop up here as its AZ copy is busy loading up files. And what you can see here is the files are dropping in here. Now, just to give you an idea here, remember all of these files had 2 threads, but you'll see only one file got loaded up because these tables is tiny. You know, this is AdventureWorks LT, and as you can see, these tables are tiny. We won't have multiple files there. However, when we get into larger files, let me just hit back in there, and sales order detail, that'll be a larger file there. As you can see, there's 2 files there. So that's where you can get that parallelism depending on how many files you want to load up there. So that's going on. I'll head back into Biml Studio, and I'll actually refresh the metadata here. So when I build it out again, we should be able to see those additional batches coming through there. Right. So the next thing I want to do is, now that we've created the packages to extract our source system, and bearing in mind is we can extract from source, we can extract CDC. So if you've got a SQL Server with CDC enabled, we can extract that. If you have a table where it's got, you know, last modified date, we can extract deltas on that. So we can configure parameters. If you have nothing, we obviously will extract a whole table, but there's so many different options in getting that data out. Once all of this, let me just see if that is finished. Right, great. So that's finished, and I now will have in Azure Blob Storage, I should now have all of my tables there. I'll have customer underscore address rather than customer hash address. And then what I'll do now is I'll head back into Biml Studio. Now, because we are using ELT-based coding, we don't really need SSIS from this point forward. Everything that we do now will actually be stored procedure scripts or SQL scripts. The first thing we need to do here is we've created the Polybase, the Azure Blob Storage tables. And the first thing you need to do to actually go and connect to those tables is to create what is called an external table. And we have these utilities that actually creates all of those scripts for you, including using an extension point. We will have the file format put in for you. Now, everything that I do from this point forward, or actually anything that I did from the start, except obviously the metadata editing, can be automated with continuous integration. So this, where I'm now clicking and saying copy this script and paste this script here, that can be totally done through a continuous integration process or automated. I'll head over to my BimlFlex Azure SQL Data Warehouse. I've got no Polybase, no external tables there right now, and I'll just drop this in and I'll run this. So this will now create all of my Polybase tables here, and if I just do select top 1000 from here, I should now get data back. So this is now reading the file. Okay. All right, that was just Visual Studio, Management Studio giving me a nice error. But what you can see here is we've actually tested this on all kinds of crazy characters to make sure that the UTF-8 conversion bit works. And that's it. That's what we've got there. Now that you have your tables in Azure Blob Storage and you have your external tables put over the top of it, we now can go and actually start building our data warehouse. Okay, and this is where I think it gets really interesting. You know, extracting data and staging it is not the most exciting thing in the world. What we can do now, remember what I said, is you can go from, I'm not going to use the word Polybase the whole time. Let's just say you can go from staging, which is your Azure Blob Storage. You can go from staging and then actually do a couple of different paths. You can go from a staging table into a persistent staging table. In other words, you can say, this table, I want to keep a copy of that table in my Azure SQL Data Warehouse, and I want to append to it. So if I want to have the customer table here, I want to have similar to an ODS style table there, where it's an online copy of my source system. Or I want to have a table that is not persistent. with this flag yes here. In other words, I want to truncate and reload it every time that I'm loading it. Or you can actually just build a view over the top of some of your tables or all of your tables, build a view and say I'm going to go directly from that view into a fact table. So you can build views directly over your staging tables, or you can take your staging tables and put that into a persistent layer or an ODS, or you can take a view and you can create either a view over the top of it, or you can build what I would just call a metadata view. Whereas in this case here, I've just put a big old left outer join in here and aliased it, and I'm creating effectively a view in metadata. Or you can create a view on the database. It depends on your preference. When we get into the columns tab here, again, I've just filtered this on the customer just to talk about the different dimension and data mart options we have here. You can do a couple of different things here. You can obviously define a surrogate key with a identity. Now, I'm not sure how much you track what's happening in Azure SQL Data Warehouse. So the identity was added in the last couple of months. So before this, we had to do some, I suppose, some gymnastics to get a surrogate key identity in there. But you can create an identity column here with a surrogate key. You can define columns as either type 1 and or type 2. So what we do here, if we have a dimension where all of the columns are type 1, then we create a type 1 dimension. If we have a dimension where all of the columns are type 2, we create a type 2 dimension. If we have a table like this where I've mixed my type 1 and my type 2 attributes, we create what is probably known as a type 6 dimension, where we will have type 1 and type 2 attributes in the same dimension. So we support all three of those options there. The next thing we definitely want to know and be aware of is that you can define what is called a hash distribution key here. What we do with that is if you have and you will probably have this if you're loading a lot of financial data or sales data, you'll have this context of, well, there's a sales or the header and a sales or the line, or there's an invoice header and a invoice line, or journal header and journal line. Now what you want to do, because within Azure SQL Data Warehouse, it obviously distributes that data across multiple nodes depending on how many you've got configured. What you want to do is you want to say that the header information and the line information need to be distributed by the header key. So the sales or the header ID may be common in these two tables. And then what you want to do, instead of distributing it by the business key or the primary key, you want to distribute it by a very specific column. That is so important when you do Azure SQL Data Warehouse. You know, we've had queries that runs for 2.5 to 3 minutes, run in 1 or 2 seconds by just giving it the right hash distribution key. So if you're using BimlFlex, or if you're building something to do with Azure SQL Data Warehouse, you have to absolutely support that. Yep. So we'll make that type 1. The next thing you want to do is possibly have the option to interact with some of the other advanced features in Azure SQL Data Warehouse. And what we can do there is, and I've just picked a couple here, is you may want to, on a table, and I've specified this on a DIM product, you may want to put distribution round robin, which means that you don't have to give it a distribution key. It just randomly distributes it anywhere. And you can use that for your dimensions. The other thing that you may want to do, which is again also fairly newly has been implemented very recently in Azure SQL Data Warehouse, is this distribute replicate, where it will replicate. If you've got a small dimension that's used a lot, you can use distribute replicate, and it will then replicate that data to every single node, which will make queries a lot faster. You may want to do that with dimensions like product dimensions and customer dimensions, where they are used a lot to join to the fact tables. The only thing to watch out for that is that if you are using distribute replicate, you cannot have your table with an identity column. So again, some of these things you may think, oh, well, I'll get to that later, but you do want to think about whether you're using surrogate keys and whether you're using just the business keys, because these things do have an impact on your modeling. We support all of that. The next thing you want to do is, or may want to do, is use the row store index. And the default for Azure SQL Data Warehouse is to use column store indexing. And personally, that's all I use. But we have the option here that and I've switched it on here on the customer here. Sorry, I want to leave that one as round robin. And I've switched it here on on the row store index. The reason why that is you may have a dimension, or you may have a table that instead of having column store index on it, you may want to have a row store index on it. I don't know under which scenario you want to do that, but it allows you the functionality to do that. I'm not going to set that, I don't need to. So now I'll head over to Biml Studio again, and as I said, it's at this stage, everything is SQL based, so you'll see a lot of me deploying SQL scripts here. The first thing we want to do is we want to do and create the Azure SQL data warehouse. We'll create all the tables that we need. So we're going to create a couple of dimensions, a couple of facts, and a couple of sort of persistent layers. And I'll go through this code in a little bit in a second on this when I have it in Management Studio. Here is all of my tables all defined now. I've got my customer, my product, and my fact sales. I have my two staging tables. I'll now hit again. Now I've got my table structure there. The one thing to probably note at this point, and you'll need to figure out how you're going to do this. Currently, there is no tool on the market that will do what a DAC pack does, or does what SQL Compare does, where you can compare your development database against your production database, and it tells you what the differences are. So one of the it's not a BimlFlex limitation, but one of the things you have to take in consideration, we actually have some Biml scripts that will compare to Azure SQL data warehouses for you and tell you which files are different, based on reverse engineering the schema into Biml. But what you need to do is you'll probably need to work out a way that you are going to deploy data, and how you're going to identify which objects have changed. And it's a little bit of a challenge at the moment, but that's not a BimlFlex challenge. That's a Azure SQL Data Warehouse tooling challenge. There's no tools that does that at the moment. So just bear that in mind if you embark on this project. So I've created my tables now. The next thing I want to do here is just go again and grab my persistent procedure script. So this is the stuff that's going to load from my staging layer, or my Azure SQL, my blob storage is going to load it just into a staging table. And this is important because what you want to do here, in the, sorry, let me just zoom this out here. What you want to do in this space here is, if you think about data warehousing or data mart writing, is quite often you have very complex business logic and even aggregations that you want to split up into multiple stages or multiple phases of delivery. So you want to go, okay, well, I'm going to go from source or from staging, and then I'm going to apply a certain amount of business logic, and then on top of that business logic, because I want to reuse that possibly in many different places, you want to go from that staging table into a data mart table. So you can have as many of these layers as you want. But just to point out here, this effectively will load into a staging table, and then the next thing we have is, so as you can see here, this has got, sorry, I'm scrolling up and down here. As you can see here, I'm doing kind of a CTAS at the top here, which is called the create table as, because Azure Blob Storage, Azure SQL Data Warehouse doesn't have merge statements, you have to do this, I suppose, SQL gymnastics and do left joins and do create table as statements. But take it from me, it's done in the most optimal way that you can. The next thing I want to just point you out here is the one for the is not persistent, which effectively is just a truncate and reload. Okay, and as you can see here, we're doing all kinds of hash bytes and regenerated code. Here is some of that data preparation that we had to do for Polybase, is where if you have a source table that has a line break in it, if you load that into a flat file and then try and load that into Polybase, Polybase just says, sorry, can't do it. Polybase is also very temperamental with dates, so we have to prepare dates in the right way. The way we handle that is we have this thing called data type mappings, where what we can do here is we can actually define different types of mappings where you can map source data types. So you can actually say, well, if I've got an Oracle data type of the following thing and it isn't very compatible, or you have a source system that isn't very compatible with a target system, you can go and define these sort of global data type overrides that will tell you that if I'm taking a date in, I need to convert it in a certain way so that it makes it, I think, polybase friendly or even SSIS friendly. Okay, so that's a neat way at a global level to configure data type conversions between different systems. Now let's head into this. I'm going to go ahead and just do exactly the same thing and create my data mart store procedure script. Now remember, I've got 2 dimensions and 1 fact table here, okay, that I'm doing. And this will do, as I said, this will do type 1, type 2, and type 6. And I'll just put it here. What I can, one thing I want to point out here is that just for 3 tables, 2 dimensions, 1 fact table, I'm already at 1,000 lines of code, or near 1,000 lines of code that has just been generated for me. Now, bearing in mind is with extension points, you can interact with some of these components here, but let's just say that unless you have, for those real corner cases, you may want to script some custom logic. The good thing about this, and one of the things that feedback that we're getting from our customers quite regularly, is because all of the code is visible and you can tweak the code using extension points, but because all of the code is standard Microsoft SQL Server code or Azure SQL Data Warehouse code, you can, even if there is a bug in BimlFlex, which, you know, it's software, there's going to be scenarios where that we haven't accounted for. Even if that does exist, you can still generate it out and tweak the code so that it works, and then log a bug with us so that we can fix it for you. None of our code, even our database, our metadata database, none of our code is encrypted, except obviously the code that we use to generate it out. So our IP is obviously wrapped up in a bundle, but none of the output or even our metadata database is locked or encrypted, so you can always see exactly what we do and how we do it. And that's one of the things that we at Verigence decided very early on to have an open framework where people that use it aren't locked away and saying, oh, well, we just can't get into this tool and change it and fix things. But yeah, that's it really. So now we build out our stored procedures to load that data. And as I said, using this approach, we are getting, you know, it's 10 to 20 times faster than using SSIS, using this ELT-based approach for loading Azure SQL Data Warehouse. And really, that's the only way I think you should use it. Now, that's probably enough on that, enough code pasting there. But yeah, as I said, that's really our template and how we've built the Azure SQL Data Warehouse framework. It's infinitely flexible. We've got a number of customers already using it. And the feedback has been really positive, but again, you know, it's version 1 of the tool, so I'm sure it'll be changing over the next couple of weeks and months. So I'd just like to thank everybody for taking the time to watch the presentation and the webinar.